In this video, I'm going to focus on the first part of section 3 of the Intro and Background unit for AP Chemistry. I'm going to talk about the EMR problems in this video. This particular section is going to be broken up into smaller videos, and this first one is just going to be on the EMR stuff. Again, we did cover this in honors, so I'm only going to be going through really the stuff that's new here. So you might have to go back and look at some of those videos from honors if you need to refresh yourself about some of these topics. We know that there's three equations here with these types of problems that we need to worry about. And I'm not focusing on the C equals wavelength times frequency in this video because we have already done that and there's nothing really new with that one. But I want to talk about the energy stuff here. So the second equation that you need to know is E equals H times frequency. Now the good news is AP does give you the C equals wavelength times frequency equation and this equation on your equation sheet. It also gives you the speed of light, c, and Planck's constant, h, right on the equation sheet. So that's good. However, if you do need to use this equation, you would have to basically know it or realize that you can solve the c equals wavelength times frequency equation and plug in to this equation in order to get this. So that's something you kind of do need to pay attention to. But if you remember here from honors that in these equations, E is the amount of energy. And we just focused on the units of E being joules. But here we really need to realize that when we're calculating the energy, we're calculating the amount of joules for every photon. All right, so that's a little different here. You do need to realize that the units for E are going to be joules per photon. And then everything else remains the same in terms of the units. Frequency, we want hertz. If we're dealing with wavelength, we want meters, and so on. So the other new thing here, besides we're calculating E in joules per photon, is they might ask you to calculate this for 1 mole. Well, we realize here that there's 6.02 times 10 to the 23rd photons for every 1 mole. Just like there's 6.02 times 10 to the 23rd atoms for 1 mole, there's 6.02 times 10 to the 23rd photons for 1 mole. So you may have to use this value in order to find this amount of energy for every mole. So just be careful with that. Definitely pay attention to this. Remember, E here is going to be in joules per photon, and you might have to use the 6.02 times 10 to the 23rd photons for every mole here in some problems, which we're going to look at here since this is new. Let's do an example here. Again, I'm only really focusing on this new stuff. You definitely need to be able to use all the equations here for these EMR problems and be able to do any of the problems. So this problem says, what is the energy in kilojoules per mole of 1 mole of photons of blue light with a wavelength of 3.60 times 10 to the minus 8th meters? So if you remember how to approach these problems, you always want to say, okay, I know I have the three equations. So this is actually a nice little review. We know we have C equals wavelength times frequency. We have E equals H times frequency. And then we know that E equals HC all over wavelength. So when you're approaching these EMR problems, you need to know your three equations and say, okay, which of the three equations am I going to use based on what they gave me in the problem? So I see in the problem that I'm solving for energy. They're asking, what is the energy? So immediately, this first equation is gone because it doesn't have energy in it. And then I notice that they gave me wavelength. So of my two remaining equations, the equation I must use is the last one because that has energy, which is what I'm looking for, and wavelength in it, which is what they gave me. So I know that I'm using that equation. For AP, you need to make sure you're writing down the equation you're using. Even if it's on the equation sheet, you have to write down the equation that you're going to be using. So now we're ready here just to plug in because we're solving for energy. But remember, in this problem, if we're solving for energy, our units are going to be joules per photon. And they're asking us the energy in kilojoules per mole of 1 mole. So that's something to pay attention to. So let's plug in what we know. H is the constant. It's going to be 6.63 times 10 to the minus 34th joules times seconds. You're more than welcome to use the number that they give you right on the equation sheet. They go out like another decimal place. It might change your answer slightly, but usually with sig figs, everything's pretty close. So that's fine. I just have that number memorized here, rounding it. So that's the number I use. Speed of light, c, is 3 times 10 to the 8th meters per second. Again, the equation sheet gives you maybe a little bit longer number. You're more than welcome to use that number. All over the wavelength, which they told me was 3.60 times 10 to the minus 8th meters. Remember, we want to be in meters here for wavelength. If it wasn't in meters, we'd have to convert. So we're just solving for energy here, so you do have to do your math. Be careful with your parentheses and your exponents on your calculator. Sig figs, base it off of the wavelength. So 3 sig figs, it's going to come out to be 5.52 times 10 to the negative 18th. And your units here are not just joules. You're solving for energy, so your units are joules per photon. All right, so we got the joules per photon, but we want to know the kilojoules per mole in 1 mole. All right, so the beautiful part is we're using 1 mole, so that's good. So we have to do some more converting here. We have 5.52 times 10 to the minus 18th. Remember, your units are joules per photon. And then we're trying to get to kilojoules per mole here. So we need the photon to cancel out and the joules to become kilojoules. So we said we know that there's 6.02 times 10 to the 23rd photons here for every 1 mole. So that gets rid of photons, and now you'd be in joules per mole. So we're almost there. Remember, we only care about 1 mole here, so that makes it really easy. So we need to get rid of our joules now. So joules are on top, so they go on the bottom. So we know here that there's 1,000 joules for every 1 kilojoule. So joules cancel. Your units would be kilojoules per mole here. All right. So when you plug and chug this with proper sig figs, we should have 3 sig figs here. It should come out to be 3,320 kilojoules per mole with proper sig figs. All right, so remember here, we were looking for kilojoules per mole. So even though our problem gave us joules per photon, we have to convert that and get to the units we want. So this was kind of showing you some of that new stuff here that's AP using joules per photon and maybe using 6.02 times 10 to the 23rd photons for every 1 mole in these problems. We can try one more problem here. You're more than welcome to try this on your own, go through it, and then come back and see if you got it, but I will walk through the problem with you. So this one wants to know the frequency of the photon from the previous problem. So I just want to show you again how to work through this in terms of thinking through it. So we have our 3 equations. We would have C equals wavelength times frequency. We would have E equals H times frequency, and we would have E equals HC all over frequency. So we want to know the frequency. So we can pretty much assume here that this one is gone because it doesn't have frequency in it. And then I have 2 equations remaining. Now, remember, in the previous problem, we did solve for the energy. So we could use this equation because we found the energy and we could solve for the frequency. But if you remember, they gave me wavelength in the original problem. So that means I also could use this equation. And since the wavelength was given, and I know that answer is correct, I'm opting to use this first equation because I don't want to have to worry about did I calculate the energy correct or anything like that. So I'm going to use the C equals wavelength times frequency equation. Remember here, use the equations and write them down as you're using them because you have to show which equation you're using here for AP. So let's plug in. C is 3 times 10 to the 8th meters per second. Wavelength they gave me in the problem was 3.60 times 10 to the minus 8th meters. Remember, we want wavelength in meters, and we're solving for frequency. So when you plug, chug, and solve with correct sig figs, it should come out to be 8.33 times 10 to the 15th. And because we're solving for frequency, our units are going to be hertz. All right, so watch your sig figs, watch your units, make sure you're showing the equation you're using.